Welcome to The Explainer. So today we're looking at an animal most of us probably just associate with, adorable zoo visits or photo safaris. But to a cardiovascular physiologist, the giraffe is literally a biological marvel. We're going to explore how the towering anatomy of the tallest living animal on Earth holds some absolutely incredible secrets. Secrets that might just completely revolutionize human medicine. All right, let's jump right in with a number that should instantly grab your attention. 220 over 180. Now, if you went to the doctor and they read that blood pressure back to you, you'd be rushed to the emergency room immediately. No questions asked. But for a giraffe, that is completely normal. Actually, scratch that. It's absolutely necessary. Because a giraffe's head sits roughly 6 meters above the ground, its heart has to pump blood against a frankly immense amount of gravity just to keep the brain supplied with oxygen.
Which leads us to a really fundamental medical mystery, right? How on earth does an animal survive this without its heart just exploding? I mean, it's a serious question. If a human being walked around with a chronic blood pressure of 220 over 180, the physical toll would be devastating. The intense pressure would literally force water right out of our blood vessels. We're talking severely swollen legs and ankles, catastrophic kidney failure, and our hearts would simply give out. And yet giraffes are just out there, grazing peacefully in the treetops, completely unbothered. How?
Well, to understand how they pull this off, we really have to look at the anatomy of a giant, because giraffes have evolved these incredible mechanical hacks to fight gravity. First up, the engine itself. They've got a massive 25-pound heart pumping out a powerful beat. But the plumbing is just as crucial. You might be wondering, why don't their legs just swell up from all that pressurized fluid pushing downward? It turns out giraffes basically wear natural compression socks. They have this incredibly tight, dense connective tissue on their legs that physically stops fluid from leaking out and pooling. Plus, they have these thick-walled arteries right near their knees. Think of it like putting a sharp kink in a running garden hose. These natural restrictors lower the blood pressure in their lower legs, keeping their tissues totally protected. It's brilliant.
But here's a curveball. What happens when that massive 6-meter neck has to lower all the way down to the ground just to get a drink of water? Gravity suddenly shifts, right? So all that highly pressurized blood should logically rush straight down into the brain and cause massive fatal damage. Well, enter the rete mirabili. That's Latin for wonderful net, and honestly, the name hits the nail on the head. It's this incredibly complex biological safety net of arteries and veins tucked right at the base of the brain. When the giraffe bends down, this net expands and constricts, beautifully equalizing the blood pressure so the brain doesn't just get blown out by the sudden surge.
And this wonderful net actually works in tandem with an even more complex fluid dynamic system we call the bending buffer. See, when the giraffe lowers its head, it isn't just the net doing all the heavy lifting. The jugular vein in the neck dramatically swells up. It basically acts like a massive reservoir that temporarily parks over a liter of blood. Because all that blood is just hanging out in the neck, less of it returns to the heart. The heart senses this drop and actually temporarily backs off, generating less pressure with each beat. But okay, here is the really clever part. When the giraffe suddenly raises its head back up to the treetops, a move that makes us dizzy just standing up off the couch, that stored liter of blood rushes straight down the neck and back into the heart. The heart feels that rush, responds with a vigorous, high-pressure stroke, and instantly shoots blood right back up to the brain. Boom, no fainting.
Now, when you compare a human heart to a giraffe heart under chronic high pressure, the differences are pretty striking. In us humans, high blood pressure forces the left ventricle of the heart to work major overtime. The muscle thickens up, sure, but crucially, it stiffens and develops scarring. That's a process called fibrosis, and it leads to diastolic heart failure, which actually accounts for nearly half of all heart failure cases in the US today. But look at the giraffe. Its left ventricle thickens to handle the massive load, but it never stiffens. It avoids that deadly fibrosis entirely. On top of that, the giraffe heart has this altered electrical rhythm that actually extends the filling phase of the heartbeat, so it can pump way more efficiently without wearing itself out.
So this brings us to a really pivotal question. We know giraffes have perfectly solved the problem of high blood pressure, but can clinicians learn from these animals? Can we take these evolutionary biological hacks and actually translate them into human therapies? The answer to that question shifts this whole story from a fascinating biology lesson straight into a cutting-edge medical thriller. As it turns out, the secret is all in the sequence. Back in 2021, scientists completed a high-quality sequencing of the giraffe's genome. They basically read the exact cookbook of its DNA. And when they compared it to dozens of other animals, they discovered something absolutely amazing. The giraffe has 7 highly unique mutations in one specific gene called FGFRL1. Now, in both mice and humans, this exact gene is heavily tied to how our cardiovascular and skeletal systems develop. When researchers saw this, they realized almost immediately they might have just stumbled onto the giraffe's genetic cheat code for surviving high blood pressure. And what the researchers did next? It sounds like pure science fiction. Using CRISPR gene editing technology, they literally went in, cut out the standard mouse FGRL1 gene, and pasted in the mutated giraffe version. Yeah, they created a giraffe-type mouse. The whole goal here was to see if giving a mouse the giraffe's genetic code would somehow just grant that mouse the giraffe's cardiovascular superpowers. Of course, to test this, they had to push these mice to the absolute limit. Enter angiotensin II. This is a drug that researchers infused into both normal wild-type mice and the new giraffe-type mice for 28 straight days. What angiotensin II does is aggressively constrict blood vessels and force the body to retain sodium. Basically, the researchers were intentionally trying to induce severe chronic hypertension and heart failure in these animals, just to see if that newly implanted giraffe gene could act as a shield. Guys, the results were absolutely staggering. The normal, wild-type mice, they developed severe high blood pressure, and exactly like humans, their hearts and kidneys suffered massive damage and fibrosis. But the giraffe-type mice? No way. They completely resisted it. Their blood pressure stayed essentially normal, and the gene completely prevented the heart scarring and organ damage. And as a completely wild, unexpected bonus, take a look at that last column we're showing here. The giraffe gene mice actually developed significantly higher bone density. So this single giraffe gene didn't just protect the heart, it was actively building stronger bones, totally mimicking the giraffe's ability to grow a massive, heavy skeleton incredibly fast. This really brings us to a quote straight from the researchers themselves, and it perfectly highlights why this matters so much. They noted, FGRL1 might be a useful therapeutic target for the prevention or treatment of hypertension and cardiovascular disease in humans. Just think about that. By simply looking up into the trees, scientists have identified a specific actionable genetic pathway. If we can develop drugs that mimic exactly what this giraffe gene does, we could potentially cure the root causes of human heart failure and hypertension. We could bypass the damage altogether. It's a real game changer. And the wild thing is, the heart is really just the beginning of the whole shebang. The giraffe genome holds even more medical mysteries that researchers are busy untangling right now. For example, giraffes are seemingly completely resistant to preeclampsia, which is a really dangerous form of high blood pressure during pregnancy that severely affects humans. Their genetics also show entirely unique pathways for platelet activation that prevents deadly blood clots from forming despite all that intensely pressurized blood zooming around. Oh, and get this, they also possess unique mutations in their circadian rhythm genes. They can function perfectly on as little as 3 hours of sleep a day without any cognitive decline. I mean, who wouldn't want that? So I'm going to leave you with this final thought for today's explainer. Could the cure to our most pressing ailments literally be grazing in the treetops? We so often look for medical breakthroughs in sterile laboratories or, test tubes, but the natural world has spent millions of years running its very own evolutionary clinical trials. The giraffe is living, breathing proof that biology can outsmart even the most catastrophic physical conditions. And by paying close attention to these towering gentle giants, we just might learn how to heal ourselves. Thanks for joining me on this deep dive, and keep your curiosity reaching high.